Hi, I'm Emma Pachuta, Project Manager for the Cedar-Isles Master Plan at the Minneapolis Park Board. I'm going to go over a few trends that the Park Board has been seeing in our lakes, as well as talk a little bit about the monitoring that the Park Board does on our lakes. So first off, this is an image of the different agencies that we partner with on water quality issues. Many of the issues that impact water quality are really need to be looked at a larger scale. Things like stormwater runoff and chloride runoff from different agency locations are really outside of our own personal jurisdiction, but obviously impact the water quality at Cedar and Isles. So we know that it takes really strong collaboration with our regulators and our neighbors to be able to have positive impact. The issues of water quality are multiple and complex. And so the strategies that we choose to put into the Cedar-Isles Master Plan is really going to be one layer of the work that needs to happen at the Park Board and then more regionally as well. So one trend that we are seeing globally as well as locally is that it's getting warmer. This graph shows the average temperature increase over the last 100 years or so in Minnesota. You can see that over the last 30 to 40 years, our weather has trended warmer by about 2 degrees. That has a really big impact on our ecological habitats here. Along with just warmer weather, we are seeing warmer winters specifically. And so warmer winters impact, how long our lake water is frozen each season. And that has an impact on things like nutrients that cycle within our lakes and the success of different living species in our lakes as well. We also know that along with getting warmer, it's also getting wetter in Minnesota. So this image shows how much additional rainfall we've been measuring over the last 100 years or so. Most of Minnesota is experiencing anywhere from a 5 to 15% increase of rainfall. And even in many locations, we're experiencing more than 15% increase. Along with more rain, we are also getting larger storms that have heavier downpour style rainfalls. And so what that can mean is that there's an increased flooding near our lakes. And that can also mean that it adds to shoreline, or with more flooding, adds additional shoreline erosion, and drowning out of native plantings, and also the drowning out of animal habitats in some instances. So how does a warmer and wetter climate, how does that translate to our lakes here at the Park Board? Well, some things that we're seeing include the increase of the blue-green algae bloom at Cedar Lake is an example of something that is a result of a warmer climate. Algae blooms are becoming more frequent in much of the Midwest due to a warmer climate. And sometimes they're showing up in bodies of water that may have had an algae bloom here and there. They're now experiencing them more frequently. And then sometimes they're actually showing up, such as Cedar Lake, where they never had an algae bloom before. We anticipate that we may see more of algae blooms as the weather continues to get warmer in our region. Some other things that we might see include new invasive species and new diseases. So an example of that is in 2020, there was a new virus, a new fish virus that was detected in the chain of lakes. And folks who went to the lakes this summer may have seen an increase of dead fish along our shoreline. So pathogens and viruses that may impact our ecosystem, again, may be able to survive here that hadn't before our weather was warmer. And then another issue might be existing invasive species that are already here that we've been able to maybe keep at bay or manage might spread further. Again, that cold winter, sometimes that keeps a lot of our plants at bay might spread further, and we are seeing instances of that as well. Another thing that we know, another impact to water quality in our lakes that has increased is the level of chloride, specifically rolled salt. And that's showing up within all of our urban watersheds, including in the lakes at the Minneapolis Park Board. Chlorides affect every aspect of life in the lake, and the impacts are irreversible. The Park Board monitors all of our lakes for chloride, and we have worked and continue to work to reduce our own chlorides on parklands though we don't have jurisdiction on the region's chloride use. So again, it really takes a village and a lot of different agencies and jurisdictions working in cohort to really mitigate these negative impacts. So looking at the chloride levels at Cedar Lake, the red line at the very top is what's called an acute standard, which is kind of like the line of no return. So if a lake's chlorides are that high, basically what that means is that organisms are just not going to be able to survive in that lake. You can see that Cedar has generally stayed below what's called the chronic standard, which is the statewide standard set by the Minnesota Pollution Control Agency that is acceptable for chloride use. But the chronic standard means that if water measures over that point for a longer period of time, over the course of several years, organisms and life in that lake will begin to struggle. You may notice that within the last few years, Cedar's levels have hit that line a couple times. So what that means is that if changes are not made regionally, the lake is at a point where the species are going to become impacted and may already be impacted to a point. You can see similarly at Lake of the Isles, generally speaking, Lake of the Isles numbers also measure below that chronic standard, but have crept up a few times over the last decade or so. So what does it all mean as we're looking forward and thinking about how to make improvements here? Well, one thing that we know is that having a robust water quality data set is integral to being able to understand and assess best methods for improvement. One thing that might be unique to water quality is it's really hard to make an assessment about how to treat water looking at one season's worth of data or even a couple years worth of data. You really have to look at data over the course of 5, 10, 20 years. And we have had a robust data source for decades. And so we have a really good starting point that we can look at and really think about what are the best strategies to use moving forward. And so some objectives that we have around our water quality, one is of course to protect the public health. So, we measure places that people swim in, that people are fishing in, and we communicate out as needed when we close things as needed when we need to. We're regularly aiming to improve our communication methods and to make sure that we're providing that information to the public in a timely manner. We also are looking to track water quality trends. So again, that happens over the course of many years of time. So tracking data over time helps us to understand both immediate and long-term changes in our water quality. It helps us to evaluate the effectiveness of the existing management practices we have in place. And it also helps to provide a basis for future water quality improvement projects. So there are 3 different things that we measure in our system. We measure our lake water quality, which is our most extensive data that we have. That's kind of what we focus on. We also monitor our beaches and we monitor stormwater. And the beach monitoring is really seasonal when people are using the beaches, and then the stormwater monitoring is a little bit more focused, like when we're having an issue or when there's a project that's coming down the pipeline. So looking at the lake monitoring schedule, this is just kind of a snapshot of how often and frequently we monitor. We monitor twice a month between the months of April and October, and then we do some sporadic monitoring in the colder weather months as well. The graph or the chart on the right is just a picture, just a snapshot and a list of all of the different things that we're monitoring when we are taking water quality samples. So again, it's a really extensive list. We have a lot of data from a lot of different things that really will help us make some good decisions in the future. And then lastly, this is a graph that's called the Trophic State Index, and it really looks at a few different layers of lake quality to get a number. The number at the top 30 means that the water is like super clear, but it also can mean there's like no nutrients or life form in that water as well. It's like too pristine. And then the bottom, kind of that 80, 90 number really means that the water is really murky. There may be lots of algae blooms that are showing up. So really you kind of want your lakes to measure between kind of the 40 to 65 number. That's kind of what you might identify as like good or better. Each lake is a little subjective based on their own habitats and their ecosystems. So there's not one perfect number that works for every lake. You can see here that both Cedar and Isles are a little kind of in the middle with where they rank in relation to the other lakes in our park system. And so this is just one of many graphs and charts that we use when we look at water quality and try to make projections and good decisions for the future. So thanks very much. I hope this information and context was helpful, and I look forward to continued conversations with you. Thank you.